In this problem, we analyze the motion of a carousel. The carousel has chairs hanging from chains. As the carousel rotates faster, the tilt of the chains will increase. Now, for safety reasons, the angle of the tilt of the chains should not exceed 55 degrees with respect to the vertical line, because at that point the circle that describes the trajectory of the chairs will be 18 meters. If the trajectory exceeds that radius, the passengers might be in risk of colliding with nearby objects. So in a diagram, we can represent the situation as follows. So we have the chain, the chair hanging from the chain, and the vertical line would make an angle of at most 55 degrees with the chain. Now, the chair is subject to some forces. We know that gravity is pulling downwards. So this is W negative mg pointing downwards. And the other force that acts on the chair is the tension from the chain, and the tension goes along the length of the chain. So we can draw our horizontal and vertical axis, X and Y, and the tension from the chain can be split into components. One of the components goes parallel to the y-axis and points up. So this would be the tension in the y direction. The other component is to the right. This is the tension parallel to the x direction, and this angle here we can see is the same 55 degrees that we have between the chain and the vertical line. We know as well that the center of the trajectory is at that point 18 meters from the position of the chair. So the radius of the trajectory is 18 meters. It will be somewhere to the right in this diagram. And the question is, what is the speed at which this angle is reached? So we keep this variable visible because this is what we are trying to find. This is the quantity we need. So how can we start this problem? We have to look at the centripetal force. Since this is a problem of circular motion, the centripetal force will be important, and we see that the centripetal force in this case is provided by the tension along the x-axis, because it's the force that points to the center of the trajectory. The centripetal force, we know that is mv squared over r, and Tx, the x component of the tension, we can see from the diagram that Tx is the opposite side in relation to the 55 degrees. So this must be the total tension times the sine of the angle. So we have the tension X is tension sine of the angle theta. From here, we can isolate the velocity, which is the quantity that we need, and we get. So we have an expression for the velocity now. So to find the velocity, we will need the radius of the trajectory, which is known, the tension, which is not given, and the mass of the chair and the passenger, which is unknown as well. So let's try to find the tension force. We will analyze the equilibrium of forces along the y-axis. So along the y direction, we have the tension along the y-axis, and we have as well the weight. Since the chair is in equilibrium, is not moving upwards or downwards, the sum of the forces must be zero. Equilibrium condition. The y component of the tension along the y-axis, we can see in the diagram that must be the adjacent side with respect to the angle of 55 degrees. So the y component of the tension is total tension cosine of the angle. So we substitute here tension cosine of the angle. The weight is the negative mg. From here, we can isolate T, the tension that we need, and we would get mg divided by cosine of the angle. So we have these two equations. We have equation 1, and we have now equation 2. And to find the velocity, we will substitute the tension from equation 2 in the formula for the velocity, which is equation 1. So we have velocity, where root, the radius. Now, instead of the tension, we use equation 2, and this is multiplied by the sine and divided by the mass. Simplifying a little bit this expression, we would have, and we see that the mass appears in the numerator and the denominator, so it will cancel, and we get Rg. Now the sine divided by the cosine is the same as the tangent of the angle. So we get this simple equation to find the velocity of the chair. We know these values, so the radius of the trajectory is 18, g is 9.8, and the tangent of 55 degrees. After doing these calculations, we get 15.87 units of velocity is meters seconds, and rounding, we will round to two significant figures because that is the number of sig figs in the quantities given in the problem, so we will round to 16 meters second. So at this speed, the angle of tilt of the chains will be 55. If we increase the speed, the angle will increase and the radius of the trajectory will be larger, and the passengers might be at risk of collisions with external objects. And we are done with this problem.